All right, so our last skill here is coming together with linear programming. So remember, we have a set of constraints that bounds what we're able to do, and given those constraints, given those situations, we are trying to basically maximize or minimize, depending on what's going on, a given function. So the first thing we have to do to start off here is actually start by graphing. So let's choose a couple different colors to use, that way we can see where everything is going, and we'll go from there. So our green function is less than or equal to y equals 10. So a nice solid line that goes through y equals 10, and it's less than, so we shade below. Our blue line is greater than or equal to y equals -5, so a nice solid line through y equals -5, and again it is greater, so we shade above. Next we have x is greater than or equal to -5, so another solid line that cuts through x is -5, and gets bigger than -5, so we're shading to the right. And then our last one here, x is less than or equal to 5. So a nice bounded region. Again, less than goes to the left. So we're going to shade where all of these things come together. And that's going to be our region of possibilities, our feasible region. All right, so anything in there is possible, and then once we get to this point, remember that next step is identifying each of the corners. So basically, where are our lines crossing here? So we have one at 5, 10. We have one at -5, 10. We also have one at -5. Nope, I messed up that last one. I take that back. We have one at -5, -5. Again, it's going over to that point there. Our next one is -5, gosh, I messed up that other point twice. So a true testament of how important it is to be careful when you go through and label these points. Just thinking too fast. All right, so again, we go to the right by 5, we go down by 5. So 5, -5 for this point. All right, back on track. This one we go to the left by 5 and down by 5, so we have -5, -5. And then the final thing, we go to the left by 5 and up by 10, so -5, +10. So we have our 4 corners. So we have 1, 2, 3, and then 4. So now it's time to take each of these and plug it into our function. So again, corner 1, we have 5, 10. Corner 2, 5, -5. Corner 3, -5, -5. And then corner 4, -5, 10. Each of these is going into 2x plus 3y. So we're going to take our x and y values and plug them in. So again, some calculator math here with our multiplication. We have 40 for our first one. For our next one, we get -5. For our next one, we end up with -25. And for our last one here, we end up with 20. So let's go back to the question, see which one of these is our right answer. It wants us to maximize, so get the biggest result possible. Well, it looks like right here is going to be the case. So we maximize the function with r equals 40 at 0.5, 10. And that is our full solution there for that linear programming question.